I think I saw David's hand.
Yeah, I was thinking 55. That's why I got that wrong.
What did 55? Thank you for looking up in the back of the book to see that you got it wrong. Too many kids do their homework and they just don't bother. All right, what did 55 say?
Y equals e to the x plus 1 over e to the x.
E to the, like this, over.
No, it's e to the x, and then I think it's separate plus 1. Yeah, plus 1 is separate. Plus e to the x minus 1.
Like this.
I don't know why.
Like that?
Yeah.
What rule is this? It is quotient rule. So we'll say y prime equals denominator, right? Times the derivative of the numerator, which is ln of the base, times the function as it is, times the what?
Yeah.
Did I copy it wrong? Oh.
It doesn't really matter.
Oh.
Good kid.
Yeah, it does.
Loading high, hidey low.
What? Well, he would do the minus 1 anyway.
No, it would have been backwards. I would have had it. It would have been a negative issue. Thank you for catching that.
Yes, Megan.
Saves the day.
Be my
And I didn't understand, and Emily explained. All right, shh. Hey. Minus numerator times the derivative of the denominator, which is, did you all do ln of the base?
Yeah.
E to the times the derivative of the exponent.
1.
And this is going to be all over e to the x minus 1 quantity squared. So this is going to be e to the x minus 1, and do you agree that's just going to be e to the x? Minus, and again, do we have e to the x? Times, now that's e to the x plus 1. What do you think you might be able to do? Well, yeah, do you think we could factor like right now? And e to the x?
Yes.
Right? Do you see they both have one? So that gives you e to the x minus 1. And now what do you do with this negative?
Distribute it to both.
Ooh, what's going to happen?
The y.
Look at the e to the x's. Whoa, what happened? So this, isn't this gone?
Yes.
A positive and a negative one gone?
Yes.
So what's negative 1 minus 1?
Negative 2.
So we got negative 2 e to the x all over.
Yes.
Is that what they had?
Yeah.
What did you do wrong, David?
I need it to cancel out e to the x. Yeah.
You mean, oh, okay. Then distribute the negative maybe? Maybe you did your Lodi high the way I did and started it off all wrong. Dev, 69. Are we hitting any of the ones you needed, Taylor? Okay, 69 said. X e to the fourth. E to the y.
E to y minus 10x plus 3y equals 0.
All right, what kind of derivative is this? Implicit. What kind is this? Product rule. Did you all see product rule? Did you miss it? You know, to be honest with you, it is so easy to miss this. All right, you see multiply, ask yourself, are there variables on both sides? So the first, now, how do we do this derivative? ln of the base times the function as it appears. Now, what's the derivative of y? 1 dy over dx, and that's another area that is easily missed. So now we're going to say the second one, and the derivative of the first is 1 dx over dx. What's the next one? 10 dx over dx plus 3 dy over dx equals 0. All right, so I'm going to go through here. That's a dx over dx. That's a dx over dx. So that is a big fat 1. So we've got x e to the y, dy over dx. And then I've got plus 3 dy over dx. So far, so good? I'm adding 10, and I'm subtracting e to the y because they don't have a dy over dx. Now what do you have to do? So we're going to factor out a dy over dx, leaving us with x e to the y plus 3. And then what do we do? You know what? I don't know. I haven't looked at your test in a while here. I'm just thinking that there's got to be an implicit differentiation on this test, too. I'm sure there is. There's got to be.
What do you think this test is?
I have no clue.
Never.
Well, just go through your spreadsheet and just tick off the days, and you'll know. Because it's basically one assignment a day. We're right on schedule. All right, Taylor, what have I not done? What did 53 say?
Y equals 2 over e to the x plus e to the x.
All right. So because it's just a 2 in the numerator, I'm going to choose to do this to the -1. Now, if there were an x, I would do quotient rule. So this is chain, correct? So do you agree that's -2 times this to the -2? And the stuff inside does not change. Now, notice my use of parentheses. We're doing the derivative of the inside. ln of the base times the function as it appears times the derivative of the exponent. Plus ln of the base times the function as it appears times the derivative of the exponent. Do you all ever talk to yourself like that in your heads?
I see, but I'm not sure.
Well, you know, I really suggest you do that. No, talk to yourself in your head. This is going to be e to the x minus e to the -x. So, who goes on the bottom?
The ex plus e to the -x.
The -2 stays on top. Why, gentlemen, why can't I simplify these? That's a minus.
It's a negative x.
Because that is minus and that is plus.
Oh.
Okay. Any other questions? Let me go to a new page. 57 said?
Y equals
Sine x plus cosine x? Okay, what's going to be required here? Product rule. So we've got first, which is e to the x. Now, what's the derivative of sine? What's the derivative of cosine? Okay. And then we're going to have plus sine x plus cosine x. All right, I don't have a whole lot of space. ln of the base times e to the x times what? So we have e to the x, and I've got cosine x minus sine x, plus e to the x times sine x plus cosine x. What can be factored? E to the x. All right. So I'm going to have cosine x minus sine x plus, what happens to the sines? So the sines are gone. And how many cosines do you have? That's an x. So I'm going to put my 2 up front. There it is. Was this bad? So you all were good on the EOC? EOC. AP prep? Every class is called something different. So you were able to do what it said? 17 of the AP prep, page 156. All right, so as we look at this, k is greater than 0. What does that mean? K is positive. So if you get 2 answers for k, which one do you choose? So this is the integral from k to 6, where k is a constant. And this is, I'm going to write this as 1 over x plus 2 dx. And they're telling us that this is equal to the natural log of k. All right, so what's the only thing you can really do in this problem? Yeah, the only thing we can do is this left side. And that does require u substitution because of the addition in the denominator. What is du? All right, so this is going to become 1 over u du. All right, so now, when x equals 6, what's u? 8. When x equals k, this is going to be k plus 2. And by the way, this is still ln k. So now we're going to integrate, and do you agree that's ln absolute value of u? So that's going to be evaluated from k plus 2 to 8. And that's supposed to equal ln k. So now, and to be honest with you, I have no idea where this is headed. Okay, so we're going to have ln 8 minus ln of the absolute value of k plus 2. But did I really need that absolute value? No. Why? Because it's positive. So I'm going to keep ln 8 on this side, and I'm moving everything. I'm going to move this other one to the other side. Isn't that going to be plus ln k plus 2? Okay, you have to use your properties. What do your properties say? Right, so that's natural log of k times k plus 2. You with me? See how we got that? All right. If both of these are natural log, what must those two expressions be? Or you raise each of them to e to both sides, which gives you 8 equals, I'm distributing k squared plus 2k. You move 8 to the other side, and you factor. So you're going to have 0 is equal to k plus 4 and k minus 2. So k is negative 4 and k is 2. So which answer is it? B. Other questions? All right, so we did derivatives yesterday. Guess what we get to do today? Yes, you'll like them. Oh, there's a differential equation. Maybe we got to back up to that one. All right, so let me go here first. Now again, I'm going to give you a rule that works for everything. The derivative, now remember the derivative of some number raised to a function was what? Ln of the number times the function times the derivative of f of x. So if I'm going to integrate, and this is just going to be some number raised to the x, okay? If I multiplied by ln of the number, what do you think we have to do to undo that? Correct. So this is going to be 1 over ln of the base times the number raised to the x power plus c. 1 over ln of just the base. So this, in order to integrate, this must be 1, and this must be to the first power. If it is not, you use what? You what? Substitution. So just like we did the e's yesterday, and we were hopefully consistent in doing this, please be consistent here. So when we go into, if I wanted to integrate 4 to the x dx, what would that be? 1 over ln 4 times 4 to the x plus c. You with me? So if I have the integral of e to the x dx, what is that going to be? 1 over ln e times e to the x plus c. And what is ln e? So that will be e to the x plus c. You see, this does not disappear. This does. So if you don't practice this, you don't remember that. So let's do another one. What if I wanted the integral of 7 to the u du? 1 over ln 7 So now, are they going to be this easy?
No.
Almost.
I don't believe that. Make it easy.
So you could do 7 to the u over ln 7. Or you could do this. All right. So here we go. Oh, is that our first one?
Oh, wow. That's not a very good first one.
Here's a good first one right there. This is not just x. So what do you think you're going to do? U equals du equals dx equals, so this is going to become the integral of e to the u times 1/3 du. Now what do you think you're going to do? So we've got 1/3 integral of e to the u du. You ready? You're right. That's going to be a lot tonight. So this is going to be 1/3 times 1 over ln e times e to the u plus what? Or this is going to be 1/3 times e to the 3x plus 1. Right. Not a definite integral, we have to substitute back. Now, how many e's were in that integral? How many e's are in the next integral? 1. Remember that. What do you think u is going to be? Okay, so what is du? So what's dx? 1 over 2x du. Where can I take my 3? Out. The x is still there. This becomes e to the u, and my dx is 1 over 2x du. So what's going to happen? X is gone, and when that 1/2 comes out, it becomes 3/2, correct? E to the u du. All right, so this is going to be 3/2 times 1 over what? Ln e times e to the u plus, what's ln e? So this is going to be 3/2 e to the x squared plus c. Okay, let's look at this one. How many e's? 1. What do you think u will be? 1 over x, or x to the negative 1. What's du? Negative 1 x to the d. All right. So before I do anything here, I'm going to rewrite this as negative 1 over x squared dx. Now what do? Dx equals what? Negative x squared du. So is this going to come out well? This is going to be e to the u. This is still x squared, but look at my du when it comes in. It's negative x squared du. What happens to our x squareds? They're gone. So I'm going to bring the negative out. So I have e to the u. I can put one on the front porch and one on the back porch. All right. So how do we do this? 1 over ln e times e to the u. So this is going to be negative 1 e to the... How many e's were in each one of these problems? 1. Good question. That's going to happen. All right.
Miss Bride, you need to use arrows instead of equal signs.
Oh. No, that's fine. That equals the...
I mean, the arrows are great because there's no linkage.
Right.
I do.
That's smart.
Then you don't need to worry about
Or you just always work down.
I cracked the code.
Yeah, if you work down, if you have an equal sign, they won't.
All right. Now, how many e's do we have? 2. So, are we going to say u equals the exponent anymore? No. What is u going to equal this time? 1 plus e to the x is the inside most. Now, what is this derivative?
0 plus
0 plus ln of the base times e to the x times d, bless you. So do you agree that dx is going to be 1 over e to the x? Do you agree?
Yes. I agree. Do you?
So we have this integral. We have u on the denominator. We still have e to the x because u is 1 plus it, not just e to the x. But once we get in our dx, what's going to happen?
You have to solve for
Do you see why when you let u be something with e to the x in it, you have to have another e to the x? Because a derivative will always have one of those. So now, are you ready? When,
Wait,
yeah.
x equals 0, u equals 2.
Well, I was getting ready to do that. You ready? X equals 1 here. When x equals 1, what's u? 1 plus e. When I put 0 in here, what's e to the 0? 1. 1 plus 1 is... So now how do you do 1 over u? ln absolute value of u evaluated from 2 to 1 plus e. So this is going to look like ln of 1 plus e minus ln 2. Ooh, what could we do with this? ln of 1 plus e over 2. Why don't I need absolute value? I thought about that. E is 2.718. All right, you can always be on the safe side.
See what time you need extra values to give a variable? But if you put it in all the time, then it's like not worth it.
No, right. Okay, you ready? What do you think u will be this time? Okay, can we leave this angle as it is and not do u substitution? No. So what is du? ln e e to the x times 1 what? So what is dx? All right, so this e to the x stays. That becomes cosine u, but when I substitute for dx, what will happen? They do, don't they? So now this is going to be the integral of cosine, and I'll do this. Cosine u du, yes. What is ln e? Okay. Now, when x equals 0, what do I have? E to the 0? 1. When x equals negative 1, what do I have? Or e to the negative 1 for the moment. What's the integral of cosine?
No, it's just sine. You never have negative.
When the answer is a co. E to the negative 1 to 1. All right, so what do we have? Sine 1 minus... I refuse to take out a calculator, so it stays that way. So much less work not to use a calculator, seriously. They want an answer, and it's decimal city. I like fractions.
I used to like that.
Oh! Oh! We are going to do a differential equation. All right, this was the last problem on the last test. Some people did not separate. Oh, so sad. So what do we do first? Now, what does this problem not have that the other one on the test had? There were no y's on this side, were there? Should have put some. Have I separated? Do I need u substitution? What is u? Okay, why didn't you make it e to the 4x cubed? There was only 1e. 12x squared dx. Or 1 over 12x squared du. Yes. So we need to integrate. What's the integral of dy? Okay, so this is going to be y, but in the meantime, this is going to be x squared, e to the u, right, times 1 over 12x squared du. What happens to the x squareds? They're gone. They simplified. And what are we going to do with our 1/12? We're going to bring it out front, and we got the integral of e to the u du. So how do we integrate that? Y is going to equal 1/12 1 over ln of the base e to the u plus c. And what was my u? 4x cubed. So this is y equals 1 over 12, and that's going to be e to the 4x cubed plus c. Sorry, I didn't give you a number. Do you know how to take it from here if I gave you a number? Okay. I wonder if we have an average value. You think we have an average value? If not, I'll make one up. No, not allowed. We need to do it. Oh, look at that. Oh, look at that. All right. And guess what's on your next test?
Oh, that's easy.
What's your domain? Well, now wait a minute. Isn't that over e to the x? E to the x cannot be 0. So if I were to natural log both sides, natural log e to the x, what's the problem with this? Can you natural log 0? So is e to the x ever 0? So that means we can go negative infinity to positive infinity.
Wait, what?
I natural log both sides. Can you natural log 0?
But then you still can't have 0.
Okay, do you know what the graph looks like? This is what the graph looks like. It's an exponential function. It passes through 0, 1, and it goes something like this. Well, how do you graph 2 to the x? 2, 4. Okay, so it's going to look something like this. Is it ever on the y-axis? No. Does that help? Okay. Now what do we do? What do you do next? What's the derivative of 1? What must go on here? 2 plus x. Are you ready? Times what? ln of the base times e to the negative x times negative 1 plus e to the negative x times 1. Do you miss this, Valerie? 2 plus x e to the negative. Ooh, there's a negative. I'm distributing it. Plus e to the negative x. What do you think you're going to do next? Factor out a what? You factor out an e to the negative x, leaving you with negative 2 plus negative x, and this is going to be plus 1, right? Which is going to be negative 1 minus x over e to the positive x. So now what do you do from here? We're going to take this and set it equal to 0, and then what do we do? 0 equals negative 1 minus x, or x equals what? Negative 1. Where is this derivative? Because there's the derivative. Where is y prime undefined? When the denominator equals 0. Is that possible? No. So when you go to do your table, what's included in your table? Negative infinity to negative 1 and negative 1 to infinity. Negative infinity to negative 1 to infinity. Test values. Ooh. Negative 2. 0. So now let's go to y prime. Here it is. It's going to be negative 1 minus a minus 2 all over e to the negative 2. Is this, let me ask you this. Is this ever going to be negative? No. So we really only have to worry about the numerator. So this is positive. Now what happens when we do negative 1 minus 0? So we're increasing, decreasing. What do we have? We've got a maximum at negative 1. Let's go back up to the top. Negative 1. What's a negative negative? Positive. So that's going to be e. So that's going to be 1 plus 2 minus 1 is 1 times e, or 1 plus e. So this is 1 plus e. So now what do you have to do to do points of inflection? Oh, quit complaining. Denominator times the derivative of the numerator. Agreed? Minus the numerator. Okay, how do you do the denominator? All over. How do you do e to the x squared? Pardon? Okay, how do you do x squared to the 4th? You multiply and get 8. What are you going to do to those babies? 2x. I did call them babies. So, what can you factor? So, e to the positive x? Okay, leaving me here negative 1. So that's going to be gone. That coefficient's negative 1. Now, did you notice I distributed my negative to get a positive? 1 plus, yeah, look at that. Okay. Now, talk to me about what simplifies here. How did I get x over e to the x? What do you do to exponents when you divide? Don't back up, I'm not done. You subtract. So now what are we going to do with the second derivative? We're going to say 0 equals x over e to the x. What happens to e to the x? So we get 0 equals x. Where is double prime undefined? Never, because e to the x is never 0. So what kind of table do I have this time? What are my intervals? Negative infinity to negative infinity to 0, 0 to infinity, test values, negative 1, 1, and now I need my second derivative. All right. Second derivative is right here, correct? Do you agree the denominator is always positive? So when x is negative, x is positive, what's happening? Concave down, concave up, point of inflection at? Point of inflection, 0. Oh, we're going to find it. 0. 0. What's e to the 0? 1. What's 2 or 1 plus 2 plus 0? 3. See, that wasn't that bad.